So we have done factoring with trinomials in every way that you can. We've done factoring by grouping for 4-term polynomials. This is another set of special cases here, all right? So for binomials, we had the difference of squares, a squared minus b squared, and that equals a plus b, a minus b. This is the difference of cubes. There is also a sum of cubes, okay? So there is no sum of the squares. If you have sum of squares, it's not factorable, other than taking out a common factor potentially. But for cubes, if you have 2 terms that are both perfect cubes, then you can do the sum or difference, and the factoring will work. Now, I will say it's easiest just to memorize these, just like the sum and difference of, just like the difference of squares. The pattern is there. You can see the pattern. So if you look at these, we have a cubed plus b cubed. So you take the cubed root, all right? So if it's 8, it would be 2. If it's x cubed, it would be x, okay? The cubed root. And you're going to add those together. If it's plus, you're going to start with a plus. And then you're going to have the square of the first minus the 2 just multiplied together plus the last one squared. All right? The only difference in subtraction are your signs. So that's why you just need to pay attention. When you subtract, you start with subtraction first, and then you do plus plus. Okay? So when you're memorizing these, when it is your sum of the signs, your factoring is going to be a positive, a negative, and a positive. When it is the difference of the sums, or difference of the cubes, it's going to be a negative, a positive, and a positive. Okay? But the factoring is the same. It's going to be a plus b, parentheses, a squared minus ab plus b squared. And then for subtraction, a minus b, a squared plus ab plus b squared. That trinomial that is created is never factorable. It is never factorable, okay? So which we are going to be solving polynomial equations, you must use your quadratic formula to solve that particular piece of it. Like, you'll be able to set this guy equal to 0 and solve. It's just a binomial. But this one will require the quadratic formula, okay? So it's never factorable. It is always going to result in a root, and possibly an imaginary, okay? But it's not factorable. Never will be, all right? So you need to memorize those, because that's the factoring that's going to throw you. If you get 2 cubes and you're like, oh, it's not factorable, it actually is. All right, so this is the example, x cubed minus 8. You can easily see those are for perfect cubes. X cubed has a cubed root of x, 8 has a cubed root of 2. And so my a here, my a is going to be x, my b is going to be 2. And then I'm just going to plug it into that factoring. It's going to be a minus b, and then a squared, well, that's x squared, plus a times b, that's x times 2, or 2x, plus 2 squared, which is 4. Okay? So my a is x, my b is 2, and then I just plug it in. A minus b, a squared, plus ab, plus b squared. I am done. That factoring is finished. Through it. So this is a cubed minus b cubed, right? You have a perfect cube minus a perfect cubed. Your factoring for that is something that we just went over, right? It's those 2 things here. So the factoring is going to be a minus b, a squared plus ab plus b squared. The first thing you want to do is establish what your a and b are. So you're going to look at these individually. What is the cubed root of 8x cubed? The cubed root of 8 is 2. The cubed root of x cubed is x. 2x times 2x times 2x is 8x cubed. Okay? So this is my a. What is my b? So I'm going to look at my second term. What is the cubed root of 1? Any root of 1 is 1. So my b here is 1. Then I literally just plug it in to this formula that I have memorized, the factoring for it. A minus b, 2x minus 1. Okay? then a squared, that is 2x squared, plus a times b, 2x times 1, plus b squared, 1 squared. My rule for squaring is I square everything on the inside. 2x squared is 2x times 2x. That is 4x squared. So I'm going to leave this alone. I'm going to simplify this. 2x squared is 4x squared. 2x times 1 is 2x. 1 squared is 1. If I were to distribute 2x minus 1 through to that trinomial, I would get my 8x cubed minus 1. So you can check these by foiling, by distributing, right? And everything will cancel out except for the 8x cubed and the negative 1. Everything else will cancel out, all right? Make sense? So now that we have mastered factoring, we are going to solve, all right? All right, so you'll notice, okay, first of all, I want to point out that if it does not have an equal sign, you can't solve it. There's nothing to solve for. I say this because some of you, when you factored on like your exam or whatever, you just told me x equals this and that, which is great, but I didn't have an equal sign anywhere in it. So how you added an equal sign in there is beyond me. So on this quiz, you're going to have some that are factoring, stop. You're going to have some that are solving, keep going, okay? So if you have an equal sign equal to 0, no less, you should keep going and tell me what x equals. If you do not have an equal sign, there's no way you can tell me what x equals because we didn't have an equation to begin with, all right? So just point that out because I've had people just solve and you can't solve if there's an equal sign. All right, so in this case, we have equals 0. It says solve. That's a key word as well. Solve, meaning I want to know what x is. Simplify or factor means I just want you to put it in simpler terms, okay? So, all right, so you will also notice that you have an x cubed. This is highly indicative of the fact that you may possibly be using your perfect cube sum or difference, okay? And so we're going to look at these. We notice, hopefully, that 27 has a perfect cubed root. The cubed root of 27 is 3. The cubed root of x cubed is x. This is my a. 1 also has a perfect cube. It is 1. So that is my b. So the first thing I want to do here is to factor, right? And so I'm going to use my sum of cubes to factor. My sum of cubes looks like this, a plus b, so 3x plus 1. And then I'm going to say a squared, 3x squared is going to be 9x squared because I have to square both of them. So 9x squared minus my a times b, 3x times 1 is just 3x, plus my b squared. 1 squared is just 1. And that still equals 0, okay? That still equals 0. Now, I will say this says find all complex roots, which is your radical roots or imaginary roots, depending on, what you have. In this case, you have imaginary. I will always say find all of them. So find all of your zeros or find all of your x. So when you're solving an equation, you set each factor equal to 0, okay? So each factor would be this is a factor and that is a factor, all right? So I'm going to say, well, 3x plus 1 equals 0. 9x squared minus 3x plus 1 equals 0. And then I'm just going to solve however I would solve. 3x plus 1, I just solve for x. Subtract 1, divide by 3. So this is going to give me a negative 1/3, okay? The other guy is never factorable. So we're going to have to use the quadratic formula there, all right? Like I mentioned, the first guy is going to be really easy to solve, subtract and divide. The second guy, you must use quadratic formula, all right? It is already equal to 0, so quadratic formula is able to be used. Negative b plus or minus squared of b squared minus 4ac over 2a. So we should have that memorized, okay? So, all right, so we're going to take this and we're going to say this is my a, this is my b, this is my c. By the way, your negatives do apply here. So it's a positive a, a negative 3, and a positive 1 for your a, b, and c. So negative b, negative 3 is positive 3 plus or minus the square root of b squared. Negative 3 squared is 9 minus 4 times a times c all over 2 times a. All right. So this is obviously going to be an imaginary number because within my discriminant, remember the part inside the root is going to be negative. So if you look here, you're going to have 3 plus or minus. 4 times 9 is? And so we have 9 minus 36. Inside the root here, we get negative 27. And then the denominator, we have 18. Okay, we do want to simplify this guy. All right, 27 is going to be 3 square root of 3. Okay, because we have 3 times 3 times 3. 2 of the 3's pair up. They come out. 1 of the 3's doesn't. It stays in. And then I'm taking out the negative with what? An I. So I have this 3 plus or minus 3i square root of 3 over 18. I can simplify this, right? And so if you want to split it up so that you know you're simplifying it correctly all the time, I don't know, it's up to you. You can do 3 over 18 plus or minus 3i squared of 3 over 18. Or if you see the 3 comes out of all of them, I don't care how you write it. But my other answer is going to be, this guy reduces to 1 over 6. This guy reduces to 1 over 6. In your book, I think they wrote it in numerator form, but we have 1/6 plus or minus I squared of 3 over 6. Now, just to point out what I said before, I have a degree of 3. I have 1, 2, 3 answers. Okay, plus or minus represents 1/3 plus I squared of 3 over 6. 1/6, 1/6 minus I squared of 3 over 6. That represents 2 answers. So I have 3 answers to a degree 3 polynomial. Okay, you have to always use the quadratic formula here. All right, so this is higher degree factoring, but you legitimately just factor it and ignore the fact that it's a fourth. You just make sure you put squared when you factor it. Like, they do this the whole process and they substitute. I don't do it that way. All right, so I have a leading coefficient of 1 when I'm factoring a trinomial. The only thing you have to make sure is that these are even numbers, okay, for your degrees, for your exponents. If this were an odd, you couldn't really do this unless you can take one out. So I have x to the 4th, that's even. And then my second term should be half of that, x squared, okay? So if this were to the 6th, that guy should be to the 3rd, okay? Like, there should be, the first one has to be even, and then the middle one has to be half of the first one. As long as that's true, then you can do this factoring. So I'm legitimately just going to say, what are factors of 8 that subtract to give me 2? Factors of 8 that subtract to give me 2. 4 and 2. Which one's negative? So I have a negative 4 and a positive 2, right? If this were just x squared minus 2x minus 8, I would say x minus 4, x plus 2. Very simple factoring, all right? It's to the 4th power. So what I'm going to do is I'm going to use half of that, or whatever my middle term is. This is going to be x squared minus 4, x squared plus 2. Okay? Because when I FOIL this, x squared times x squared is x to the 4th. X squared times 2 is 2x squared. Negative 4 times x squared is negative 4x squared. That's how I get my negative 2x squared in the center. And negative 4 times positive 2 is negative 8. All right? So that's, yeah. So I'm just literally factoring. Now, when you have higher order, you have to make sure that you cannot continue to factor. Do I have a special case in here that says I can continue to factor? Yes, I have the difference of 2 squares. So I have a squared minus b squared in here. I have 2 perfect squares that are subtracted. My factoring for that is a plus ba minus b. This guy can still be factored. It says factor completely. So this factoring would be x plus 2, x minus 2. And then I would leave that alone. The sum of 2 cannot be factored. So this is x squared plus 2. That is my complete factoring. So you do have to look for a special case here and make sure that you are not, messing up a special case, or to continue factoring rather a special case. So first of all, to solve by factoring, it has to be equal to 0. So I have to move that 12 over. So I'm going to have x to the 4th minus x squared minus 12 equals 0. You can see that you have 4 and 2, so this is good to go. All right, so factors of 12 that subtract to give me negative 1, that's going to be, which one? What's it going to be? It's going to be 4 and 3, right? So I'm going to do this. All right. Now, you can continue factoring, right? So if it says factor completely and then solve, you would want to say x plus 2, x minus 2, x squared plus 3 equals 0. And then solve. Remember, it's equal to 0, so you need to keep going. You're not done yet, okay? So I'm going to set each factor equal to 0. X plus 2 equals 0. That's going to give me x equals negative 2. X minus 2 equals 0. That's going to give me an x equals 2. X squared plus 3 equals 0. Well, that means x squared equals negative 3. That means x equals the positive or negative root of negative 3. I need to simplify that one more time. X equals positive or negative I square root of 3. And so those answers are my x's. How many do I have? I have 1, 2, 3, 4. My degree was 4. If you look at your check understanding, if you, wait, hang on, don't do that. Just not that. Not. Positive or negative 3i, positive or negative I squared of 2.
Wait, where's the root? Why is it 3i?
Because it's factors of 18 that add up to 11. What are those? All right, so x squared is going to equal negative 9. That means x is going to equal the positive or negative I squared of 3. X squared is going to equal negative 2. That's positive or negative I squared of 2.